First, we have to graph the lines y equals x plus 4 and y equals x minus 4 and x equals 0 in the same coordinate plane. So let's copy. First equation, we have y is equal x plus 4. To draw this graph, we need 2 points. From this equation, we have y intersection point will be 0, 4. Always the expression without x tells us about y intersection. And now to find x intersection, we will put that y is equals 0. So we have 0 is equal x plus 4. So I will move 4 to the left side and change the sides next. So will be x is equal negative 4. So the second point will be negative 4, 0. We have 2 points, so we can draw xy plane. This is y-axis. And x-axis. We have to choose unit. 1, negative 1, and first point is 0, 4, for x 0, for y 1, 2, 3, 4. So this is point 0, 4, and negative 4, 0. This is second point. So we have first line, this is y equals x plus 4. From this equation we see that we have positive coefficient before x, so our line must go up. So everything is okay. Next we have line y equals x minus 2. Let me copy this. So y intercept will be 0, negative 2. And if we have to find the point which our line past x-axis, we have to put for y 0. So we have that we substitute the y by 0, so we have 0 is equal x minus 2. I will move negative 2 to the left, and next I will change the sides, so we have that x is equal 2, so we have a second point is 2, 0. So let me find these points. We have 0, negative 2. Negative 2 is here, so we have 0, negative 2. And the second point is 2, 0. So this is here. Next we have to connect these 2 points. This is y equals x minus 2. The coefficient before x is positive 1. It means that these 2 lines are parallel because the coefficient before x is the same. So let's put that this is line K, this is L. We have that K K is parallel to L, and the third line is x equals 0. X equals 0. This is our y-axis. So this is our x equals 0. We have x equals 0. We have our 3 lines. Next, we have to consider the equation y equals mx plus 1. For what values of m will the graph of the equation form triangles if added to your graph? For what values of m will those triangles be congruent? So let's consider 3 cases. Let me copy our equation. We have y is equal mx plus 1. Let's check first what will be if m will be 0. So let's use different color. For m equals 0, we will have equation y is equal 0 times x. Let me put this. We have 0 times x plus 1. So we will have equation y is equal 1. So let me draw this line. We have y is equal 1. So this is line which is parallel to x-axis. This is our y equals 1. So now we see that we got 2 triangles, and what we have in this triangle? We can count the measure of this side. This is one triangle. Let me maybe put this as our one triangle. This is our second triangle. Now we have to check if these triangles are congruent. Let's first check what we have here on this diagram. These 2 angles are vertical angles, so they are congruent. So we can write that this angle is congruent to this angle. What else? We have that these 2 lines K, L, M are parallel. So if I put that y equals 1 is our transversal, so from alternate interior angles theorem, we have that alternate interior angles are congruent. So alternate interior angles are angles which are on opposite sides of our transversal. So if this is our transversal, so alternate interior angles will be this angle and that angle. So these 2 angles are congruent. We have that these 2 vertical angles are congruent and that 2 angles are congruent, alternate interior angles. So let's see our side between these 2 angles. For y equals 1, our line passed y x plus 4 at point. You can solve always equation. For y equals 1, we have y is equal x plus 4. So we can substitute y by 1. So we have that 1 is equal x plus 4. So x is equal, I will move 4 to the left and next I will change the side. So we have 1 minus 4 is negative 3. So we have point x is negative 3, y is 1. So this is our point negative 3, 1. And the same we have to do for the L line. So we have for y equals 1, we have y is equal x minus 2. So we will substitute y by 1 in the second equation. So we have that 1 is equal x minus 2. So x is equal 3. So we have point 3, 1. So this is our point 3, 1. So now we have to just count this side. We have unit 1. We have 3, 1 points. So we have 1, 2, 3. This side has 3 units. And this 1, 2, 3 units. It means that these two sides are congruent. And the angles between these sides are congruent too. So we can write that by angle, side, angle, congruence postulate, triangles are congruent. So for m equals 0, we got two triangles which are congruent. What else? Now we have to check for the second case will be for m less than 0. So for m less than 0, we have equation y is equal mx plus 1. If m is negative, less than 0, so our line will go down. And for sure, this line will pass point 0, 1. So let's now draw another diagram, xy plane, and these two lines, 3 now lines. So let me put that. This is our y-axis. This is our x-axis. We have to choose unit, and we have to just copy these two lines, y equals x plus 4 and y equals x minus 4 minus 2. We just calculate these points which we have to put on our xy plane. So let me copy this. We have point 0, 4. We have point negative 4, 0, 3, 4. So now we can connect these points, and we have first line. This is our y equals x plus 4. Next we have a second line, x minus 2. We have 0, negative 2, first point. And the second point is 2, 0. So we have two parallel lines. This is y equals x minus 2. The third line is x equals 0. So this is y axis. And now we will draw the third line, which has m less than 0. So as m is negative, it means that our line will go down. From our equation, we can read that point of y-intercept is 0, 1. So we have here is 0, 1. Our line will pass this point for sure, and we need the second point. Because, like I said, m will be negative, so our line will go down and will pass this point. So if it doesn't matter how this line will look like, it's important that we'll pass this point, and you can draw something like this, like that. It doesn't matter. Important is only that m is less than 0, so this line must go down. We cannot draw something like this or that, because in this case we have that m is less than 0. So you can choose, for example, that m is equal negative 1. For m equal negative 1, we will have y is equal negative x plus 1. So if we put that y is equal 0, then we will have equation 0 is equal negative x plus 1. So x is equal 1. So we have a second point, 1, 0. 1, 0. So let's put that this is our line. Y is equal negative x plus 1. And we see that again we got triangles, two triangles, and these two triangles, which are formed thus by these three lines, will be also congruence triangles. Let me draw this triangle, these triangles we have now, and that. If we put down this line, we will still get two triangles, maybe a little bigger or smaller. It depends how this line will be. If it will be close to y-axis, then triangles will be smaller. And it will be farther from y-axis, we'll go to this way, our triangle will be bigger. And let's see what we have here. We have these two angles, vertical angles. So for sure here we will have congruent angles, because vertical angles are congruent angle. And what else? Parallel line. So if our line x equals 0 will be our transversal, so it means that the angles which are of the opposite side of our transversal are congruent angles. So this, let me put that this is, for example, angle 1. So here we have angle 1, 2. I just use alternate interior angles theorem, which tell us when we have two parallel lines which are cut by transversal, then alternate interior angles are congruent. So these two angles are congruent. And we see we can count, because this point is 0, 4 and that 0, 1. So this side has 3 units. And this side of our second triangle has 3 units too. We have 2 congruent angles, and the side between these 2 congruent angles is congruent. It means that our 2 triangles are congruent too by side-angle congruence postulate. Our 2 triangles are congruent. So for m less than 0, it means for m negative, our line will form triangles, 2 triangles which are congruent too. So now we have to consider the third case when m is positive number. So let's put for m greater than 0. First we will draw these 3 lines. So we need xy plane. Y-axis and x-axis. We have to draw this first line. We need 2 points. We already found this, that y equals x plus 4 intersect our y-axis at point 0. So first we have to have unit at point 0, 4, 0 for x and 4 for y. 2, 3, 4, 0, 4. And the second point is negative 4, 0. Let me copy maybe this equation. We have y equals x plus 4 and we have 2 points, 0, 4 and negative 4, 0. So this is 1, 2, 3, negative 4 will be here. So if we connect these 2 points, we have first line. This is our line y equals x plus 4. The second line is y equals x minus 2. And we have first point is 0, negative 2. And the second point is 2, 0. So first point was 0, negative 2, 1, 2, 0, negative 2, and the second is 2, 0. So if we connect these 2 points, we have second line, and these 2 lines are parallel. Why? Because coefficient before x is the same. We have 1. If we don't have any number, it means it is invisible 1. This is 1. So the third line is x equals 0. So this is our y-axis. This is x equals 0. So we have these 3 lines, and the third we have y is equal mx plus y. 1. We consider what will be when m is less than 0 and when m is equal 0. Now we have to check what will be when m is positive number. So first, if m is equal 1, we will have that y is equal 1 times x plus 1. So y is equal x plus 1. X plus 1. We see that we had the same coefficient before x, we have 1 here. It means that this line is parallel to line y equals x plus 4 and y equals x minus 2. So because these three lines will be parallel, we will not have any triangle. We can write that for m equals 1, we'll have three parallel lines. So now we will check what will be for m greater than 0 and m different than 1. So we will choose that, for example, m is equal 3. So our line, this is our line, will be y equals 3x plus 1. So we see that we have here in our equation 3x plus 1. So the y-intercept point will be 0, 1, and we need second point to draw the graph of our line. So let's put that y is equal 0 now. So if we substitute y by 0, we will have 0 is equal 3x plus 1. So we will have, I will move 1 to the left side, so it will be negative 1 is equal 3x, and now I will divide both sides by 3. 3 and 3 we can reduce, and we have that x is equal negative 1/3. So we have the second point, negative 1/3, 0. So first point is 0, 1, and second is negative 1/3, 0. So now we have to find these 2 points, 0, 1, and negative 1/3. So this is 1. We have to divide to 3 pieces, so approximately here is 1, negative 1/3. So this is our point, negative 1/3, 0. Now if we connect these 2 points, we have our line and we see that for m equals 3 we got 2 triangles. So if m will be positive, our line will be like this, or will be a little farther, but still will meet our 2 lines, y equals x plus 4 and y equals x minus 4, but not for m equals 1. For m equals 1, our three lines will be parallel. So for m positive by different than 1, we will have 2 triangles. Now we have to check if these 2 triangles are congruent. So first, let's find the angles which are congruent. We see that x equals 0 and our line, this is y equals 3x plus 1 met at this point. And we see that this angle and that angle are vertical angles. And we know that vertical angles are congruent. So we have these two congruent angles. What else? We can count that this segment has 1, 2, 3 units, and that 1, 2, 3. We have 3 units too. So this segment and that segment are congruent. What else? Because these two lines are parallel, and if we put that y equals 3x plus 1 is our transversal, so we know that alternate interior angles are congruent. So this angle and that angle are congruent. So let's put that this is, for example, A, B, C triangle, and here we have B, C, D, E. So we have that these two angles are vertical angles, so they are congruent. So we can write that angle CAB is congruent to angle DAE because vertical angles are congruent. What else we have? We have that segment CA is congruent to DA. Segment CA is congruent to segment DA. We just count this and that segment has 3 units. And we have that angle ABC is congruent to angle AED. AE, of course, D, by alternate interior angles theorem. So we see that we have two angles and this side. So by angle, side, congruence postulate, these two triangles are congruent. So we see now that for m different than 1, we have congruent triangles. So we can write now that for m belongs to all real numbers without 1, we have that triangles are congruent. So this is my solution.